All right, let's jump right into this explainer. We're tailoring this specifically for you, product managers who want to completely demystify the mechanics of natural language processing. Look, whether you're building the next smart chatbot, an intelligent search feature, or some massive sentiment analysis tool, you absolutely have to understand the core theory of how AI processes language. It's totally essential for making smart, strategic product decisions. So, let's get into it. Now, before a computer can even think about understanding a basic sentence, it runs into a giant roadblock. Human language is the ultimate messy data problem. It's unstructured, it's ambiguous, and honestly, it's incredibly messy. As humans, we just naturally have this linguistic intuition, right? We get context, we understand slang, typos, tone, you name it. But machines, they only speak math. Literally, just ones and zeros. So the big question is, how do we bridge that massive gap to actually build features our users are going to love?
Well, that is exactly where NLP comes in. The crucial thing to remember here is that NLP acts as that bridge. It takes all that messy human language and turns it into actionable, structured product features. It's basically the entire science of teaching machines to comprehend human text and speech. Think of it as the core engine powering everything from, say, routing a furious customer support ticket to the exact right department, all the way to powering the autocomplete in your search bar or instantly analyzing the sentiment of 1,000 product reviews. It does all the heavy lifting.
So here's our roadmap for this explainer. We'll start by demystifying NLP, then dive into the core engine, which is tokenization. After that, we'll look at capturing meaning with embeddings, figure out how to choose your tools, specifically NLP versus LLMs, explore some real-world product use cases, and finally, we'll wrap up with common pitfalls and ethics.
All right, part 1, demystifying natural language processing.
Which brings us right to part 2, the core engine, tokenization.
Let's look under the hood to see how we actually process this data without writing a single line of code, I promise. Our absolute first fundamental building block is tokenization. Now, that's really just a fancy word for splitting raw text into manageable, bite-sized pieces. Because NLP systems, they don't look at sentences the way you and I do. We have to deliberately decide how to slice up the language. You have a few different methods for breaking text apart. You could split things word by word, sure, but what happens when the model sees a brand new made-up word? The whole thing just breaks. On the flip side, you could split by individual characters. You'd never hit an unknown word, but your sequences would become insanely long, eating up all your memory and compute power. So what's the solution? Well, the absolute sweet spot for modern models is subword tokenization, something like byte pair encoding. This is a brilliant method that breaks words into meaningful parts, like roots and suffixes. It perfectly balances efficiency while still handling brand new words like an absolute champ. Think of these tokens as individual ingredients in a recipe. By taking a knife to the word learning and literally chopping it into learn and ing, or taking photography and making it photograph and ing, the model can suddenly understand variations of words, even if it has never seen that exact combination during its training phase. And let me be clear, bad tokenization means bad understanding. If the computer messes up this very first step, the entire process starts off on the wrong foot. It's absolutely foundational. Moving right along to part 3, capturing meaning with embeddings. Okay, so tokenization was all about structure. Now we need to talk about actual understanding. Since computers absolutely do not read English, they only speak math, remember? Embeddings are what translate these text tokens into a list of numbers. You get this dense numerical vector that somehow captures the entire semantic vibe, the hidden meaning, and the context of the word. Every single token gets mapped to a specific vector. It basically acts as a unique numerical fingerprint for that concept, all based on patterns the model picked up while reading massive amounts of data during training. To visualize this, imagine a giant high-dimensional map of meaning. Similar concepts like cat and dog are placed super close together on this map. Their numerical vectors are highly similar simply because they naturally pop up in similar contexts in human language. Meanwhile, concepts like cat and refrigerator are just miles and miles apart in this meaning space. By turning meaning into literal spatial distance, the model can instantly understand context, handle synonyms, and run lightning-fast semantic searches. It's honestly kind of like magic, but it's just really good math.
Now for part 4, choosing tools, NLP versus LLMs.
Now that we really understand the core engine, how tokens break down language and embeddings give them that mathematical meaning, it's time for a crucial pivot.
As a product manager, you absolutely must know the difference between traditional NLP and large language models, or LLMs. Traditional NLP is narrow, it's task-specific, and it is incredibly fast and efficient. LLMs, on the other hand, they're general purpose, they're generative, and they are highly complex. Look, choosing traditional NLP over an LLM can save you a massive amount of money and cut down on latency. If you're building a conversational chatbot, then sure, go ahead and use an LLM. But if you're building an email client that just needs to instantly filter out junk mail, traditional NLP is going to be your fastest, cheapest friend. Use LLMs when you actually need to generate brand new, context-rich paragraphs from scratch, but rely on traditional NLP for fast, reliable, rule-based sorting and classification.
Let's bring this into the real world with Part 5, Real-World Product Use Cases.
NLP powers an incredible array of features that you'll use all the time. As a PM, you can leverage sentiment analysis to automatically classify the emotional intent behind thousands of customer reviews, bucketing them into positive, negative, or neutral in seconds. Or you can use information extraction to pull out names, dates, and key financial data from massive stacks of business reports. That alone allows human risk officers to make calls in literally minutes instead of days. Or maybe you use abstractive summarization to condense a dense, 10-page legal contract into a neat 3-sentence overview. The possibilities here are huge.
But building these products isn't just a straight line. Because NLP relies so heavily on real-world, constantly shifting language data, you have to embrace a rapid prototyping cycle. You set up your pipeline, you deploy it quickly to collect actual user feedback, and then you evaluate. And here's the kicker. Most importantly, once deployed, you have to actively monitor your models for model decay. Language changes, user behavior shifts, and your model's performance will naturally degrade over time unless you're actively updating its training data. Think about it. A model trained exclusively on 2019 tweets is going to have absolutely no idea what 2024 slang means. You've got to stay vigilant.
Finally, Part 6, Common Pitfalls and Ethics.
To wrap up our playbook, we absolutely have to talk about the responsibilities and the common traps you're inevitably going to face when managing these systems. Because language AI is incredibly powerful, but it is far from flawless. Aside from the classic mistake of using super expensive LLMs for simple classification tasks, a major pitfall is ignoring the context window. The context window is basically the maximum number of tokens a model can process at one time. It's the model's short-term memory limit. If you overflow this window with a massive prompt, the model is just going to chop off the beginning. It'll suddenly drop your early instructions, it'll break formatting rules, and it'll start hallucinating. Why? Because it literally cannot remember the constraints you gave it at the very start.
Furthermore, we have to talk about the data itself. Models inherit the historical, statistical realities present in their training data. For example, researchers at Stanford highlighted this perfectly by looking at image search results. Queries for the word homemaker predominantly surfaced images of women, while queries for CEO predominantly surfaced images of men. Your models are basically statistical mirrors of human history, complete with all of its flaws and biases. As a PM, this isn't just an engineering problem you can pass off. It is entirely on you to test for this and to implement product guardrails so your features behave exactly as intended, fairly and safely.
By understanding how tokens structure data and how embeddings capture that hidden mathematical meaning, you are no longer treating AI as some magic black box. You know the strengths of narrow NLP models versus generative LLMs. You know the critical importance of the context window, and you understand the real risks of model decay and biased outputs. You are now fully equipped to make strategic, efficient, and responsible AI product decisions. So, with all that in your toolkit, what NLP product will you build next? Thanks so much for joining me on this explainer, and I'll see you next time.